Hello students. So already we have proved the basic proportionality theorem, converse of basic proportionality theorem. That is our theorem 6.1 and the 6.2. Now from our NCERT, so some of the examples we will be solving in this video, which will be based on the basic proportionality theorem and the converse of basic proportionality theorem. So this is our example 1. So let's see. So if a line intersects sides AB and AC of a triangle ABC. Now here in this question already figure is given. In a triangle, what is given? This D and the are 2 points, and this DE is parallel to BC. This is already given. So we have to prove this AD divided by AB is equal to AE divided by AC. Now let's see. First, given. So what is given in the question? First thing is given, this DE parallel to BC. Okay. Now given, then to prove. What we have to prove? We have to prove this AD divided by AB is equal to AE divided by AC. So given, to prove, next proof. So to prove this one, here construction is not required. So how we can prove? Here we can see one triangle ABC, and in this triangle this DE parallel to BC given. So a triangle is given and one parallel line is given. So which theorem we can apply? So we can apply the basic proportionality theorem. So by basic proportionality theorem, what we can say? This AD divided by DB is equal to AE divided by EC. But we have to prove what? AD divided by AB is equal to AE divided by EC. Now we will take the reciprocal of this. Alright, taking reciprocal. So if you take the reciprocal of this, what will get? DB divided by AD is equal to EC divided by AE. Now after taking the reciprocal, add 1 to both the sides. Add 1 to both the sides. So right, DB divided by AD plus 1 is equal to EC divided by AE plus 1. Now take the LCM. This will be AD DB plus AD is equal to AE. This will be EC plus AE. Now look at the diagram. DB plus AD. If we add DB plus AD, what will get? We will get AB. Now if we add EC plus AE, if we add EC plus AE, what will get? We will get the AC. Now what we have to prove? We have to prove AD divided by AB is equal to AE divided by AC. Now again you take the reciprocal, then we will reach to our answer. Right? Again taking reciprocal. So if you take the reciprocal, what you will get? AD divided by AB is equal to AE divided by AC. So in this way we can prove this question. So this is our example number 2, NCERT example number 2. So one trapezium is given. In this trapezium, this AB is parallel to DC given. Figure also given, figure 6.14. This AB parallel to DC given, and E and F are points on the non-parallel sides AD and BC. So these are the AD side and the BC sides are the non-parallel sides of the trapezium. And this EF is also parallel to AB. What we have to prove? We have to prove this AE divided by ED is equal to BF divided by FC. Now let's prove. So what is given in the question? Given a trapezium, first given a trapezium ABCD, and in this trapezium this AB parallel to CD or DC given, and one more information is given, this EF is parallel to AB given. Then anything else? Okay, nothing given. Then to prove, what we have to prove? This AE divided by ED is equal to BF divided by FC. Now to prove this question we have to do construction. So what construction is needed? We have to draw one line, or we have to join this AC line, and this AC line intersecting the EF point, let's suppose at point G. So you write join A to C which intersects EF at point G. Now given to prove construction. Next step is proof. Proof. Now in the question what is given? The first thing is given AB parallel to DC or CD, and one more information is given, this EF parallel to AB. Now AB parallel to CD, EF parallel to AB. Now what we can say? This EF also parallel to DC. What is the reason? Lines parallel to the same line are parallel to each other. Lines parallel to the same line are parallel to each other. Now here we have to consider one triangle. Here we can see one triangle, that is the triangle ADC. In triangle ADC. Now if I draw this triangle separately, triangle ADC, and in this triangle EG. Now in this triangle, see, in the question already we got EF is parallel to this, EF is parallel to CD or DC. So we can say that this EG line also parallel to CD. This EG line also parallel to CD line. In this triangle EG parallel to DC. Now one triangle is there and parallel lines are there. So we can apply the basic proportionality theorem. So by BPT what we can say? This AE divided by ED is equal to AG divided by GC. This one you give as the equation number 1. Now we can see another triangle, that is the triangle, this triangle is ABC. So in triangle ABC. So in this triangle also, ABC triangle, in the question it is given this EF is parallel to AB. So if EF is parallel to AB, we can say GF also parallel to AB. In this triangle, this line, this one is G, this one is F. GF is parallel to AB. Now again, one triangle is given and two parallel lines are given. So what we can apply? By BPT. By BPT, what we can say? This BF divided by FC. This one is F. BF divided by FC is equal to AG divided by GC. This one give equation number 2. Now you look at both the equation 1 and 2. In both the equation, the right hand sides are same. So if in a equation the right hand sides are same, we can equate the left hand sides. So what we can say? So we can write from equation 1 and 2, we get AE divided by ED is equal to BF divided by FC. So this one only we had to prove. So in this way we can prove this question. So this is example number NCERT example number 3. So let's see in this question what is asked. So here figure is given. In this figure, this PS divided by SQ, PS divided by SQ is equal to PT divided by TR given. And one more information is given. This angle PST is equal to angle PRQ. So what we have to prove? We have to prove this triangle PQR. It is an isosceles triangle. So first, what is given in the question? In the question it is given PS divided by SQ is equal to PT divided by TR. And what is given? Angle PST is equal to angle PRQ. These two information is given. After given, next to prove. So what we have to prove? We have to prove this triangle PQR is an isosceles triangle. So given to prove. Next is proof. So how can we prove? So see, in triangle PQR, first what is the information is given? PS divided by SQ is equal to PT divided by TR. Now you see, one triangle is given and the ratio of the two sides given same. So we can apply the converse of the basic proportionality theorem. So by converse of basic proportionality theorem. So by converse of basic proportionality theorem, what we can say? So if in a triangle, if a line divides the any two sides of a triangle in the same ratio, then this line must be parallel to the third side. So what we can say? This ST line is parallel to QR line. Now you see in the figure, these two lines just now we have proved parallel. This one is ST and this one is QR. So these two lines are parallel. Just now we have proved from the converse of the basic proportionality theorem. Now on this line, this is the PQ line. This line will act like a transversal. So see, this ST is parallel to QR, and here we can say This PQ is the transversal. So in these two parallel lines, PQ act like a transversal. So if this PQ is act like a transversal, we can say that this angle and this angle will be same. This angle PST is equal to angle PQR. Why these two angles are the same? Because these two angles are the corresponding angles. Corresponding angles. Now see, in the question, angle PST is equal to angle PRQ. This information is given in the question. And also we have proved that angle PST also equal to angle PQR. So we can write this one, proved above. Now you see, in both the equation, the left hand side is same. So we can equate the right hand side. So what we can say? Angle PRQ is equal to angle PQR. Now you see, in this triangle, the triangle is PQR. And in this triangle, what we proved? This angle, angle PQR is equal to angle PRQ. So if in a triangle, these two angles are same, we can say that the sides opposite to their angles also will be same. So what we can say? This side PQ is equal to P. Now, if in a triangle, if the two sides are same, that means it is a type of isosceles triangle. So what we can say? Hence, triangle PQR is an isosceles triangle. Proved. So these are the three our NCERT examples which are based on the basic proportionality theorem and the converse of the basic proportionality